Welcome! Today we'll solve some chemistry problems involving molar mass and converting between moles and numbers of particles. Let's start with finding the molar mass of iron 3 oxide, Fe2O3. To calculate this, we need to add up the masses of all atoms in the compound. We have two iron atoms, each with a molar mass of 55.85 grams per mole, and three oxygen atoms, each with a molar mass of 16.00 grams per mole. Next, let's find the number of atoms in 2.89 moles of zinc. We'll multiply the number of moles by Avogadro's number, which is 6.022 times 10 to the 23rd atoms per mole. 2.89 moles times 6.022 times 10 to the 23rd gives us 1.74 times 10 to the 24th atoms. Now let's solve problems converting numbers of particles to moles. The key formula here is that the number of moles equals the number of particles divided by Avogadro's number. For part A, we have 3.95 times 10 to the 24th atoms. Dividing by Avogadro's number gives us 6.56 moles. For part B, we have 3.13 times 10 to the 24th molecules of CO2. Dividing by Avogadro's number gives us 5.20 moles. For part C, we have 5.02 times 10 to the 23rd formula units of zinc chloride. Dividing by Avogadro's number gives us 0.834 moles. Finally, for part D, we have 5.42 times 10 to the 20th atoms of iron. Dividing by Avogadro's number gives us 9.00 times 10 to the negative fourth moles. Let's summarize what we learned. We calculated the molar mass of iron 3 oxide by adding up the masses of all atoms. We found the number of atoms in zinc using Avogadro's number. And we converted various numbers of particles to moles by dividing by Avogadro's number.